Hello and welcome to my video, lesson 5.2 on grade, angle of elevation, and distance. So just to remind ourselves about something from 10-3, something we would have learned last year, is the idea of Sohcahtoa. Sohcahtoa is an acronym that helps us remember what to do with sine, cosine, and tangent functions. So let's just start with sine. Oh, that's really thick. Let's make that a little bit smaller. Okay, let's start with sine. Sine of an angle, which we always write as theta, is going to be equal to the opposite side over the hypotenuse. Okay, so that is the sine function. Cos function is cos theta equals adjacent over hypotenuse. Hypot. And last but not least, especially today, since this is the one we're going to be using most of the time, tan function is tan theta equals opposite over adjacent. And for all of these, you can remember that you can use the inverse tan or the inverse sine or inverse cos, which just kind of flips it around. So it flips it on its head and changes it around a little bit. So if we have tan to the -1 of the opposite over the adjacent, it now equals the angle. So you can do that with all of them and flip them around using the negative functions or the inverse functions. Okay, with that in mind, we're now going to use this triangle here, and we're going to try to find the angle on the triangle. Now, I don't have any numbers written down, so let's try that first. Start with some important numbers. So first of all, what numbers are we going to need if we're using the tan functions? Well, we're going to need the opposite, the adjacent, and we're going to need to know which angle we're actually looking for. So we're looking for that angle. Okay, with that said, maybe we'll just talk about squares. This is 2, this is like 5. Okay, so we now have 2 sides and we have the angle. So now we need to find the angle. Okay, well, we're going to have to use, which one will give us the angle? We're actually going to have to use this one because it equals the angle. So we're going to need to type in our calculator tan -1 of opposite over adjacent, which is 2. I'm just typing in my calculator while I'm talking. 2 divided by 5, or 2 over 5. And that equals 21.8 degrees. All right, so this kind of hopefully is fairly straightforward. We just need to use those functions to find angles. Now, that's pretty straightforward when we have the 2 sides, but what if we're just, like, what if instead of it being drawn for us, what if it just tells us a word problem, like this one? So here it has, considering the street has a grade of 15%, what is the angle of elevation? Well, this 15% is actually saying that it goes up by 15 for every 100 it goes horizontally. So we can actually just draw this out, and I really highly recommend this, that you draw it out and make sure that you are careful to label the correct sides, the correct distance. But let's say it's 15 meters per 100 meters, right? So that's 15%, or you could have 15 kilometers per 100 kilometers, but that would be not really a street, it would be a highway or something. Okay, so anyways, we have 15 over 100, because 15 over 100 is rise over run, or it is slope. Really cool, because this is from our last unit, but also rise over run. If you take rise over run, you can use the tan negative function of that and get our answer. So 15 over 100, and now we can get our theta value, our angle. So let's try that out. 15 divided by 100 inside of there, and we have an angle of 8.5 degrees. All right, so whenever it says percent, it just means it's out of 100. Percent per 100. That is what it's telling you. Cent is like a cent when we're talking about dollars. It's 100, right? Okay, find the height of the balloon if it is 30 meters away at an angle of 20 degrees. So there's a little person over here standing, and they're looking over there at a balloon. Whoops, let's make a nice, more pretty triangle. They're looking over there at a balloon. Okay, it's a nice little balloon. Squiggle, squiggle. There you go. There's a balloon over there. So when they're looking, they know it is 30 meters away. I don't know how they know that. Maybe they measured it, but who knows? And they know that's an angle of, of 20 degrees. Okay? And they're asking, well, what is the height? Okay, well, this is a slightly different question because we know theta. Okay, so we need to plug this into our tan function from the beginning here. Not this one. This one. So tan theta equals opposite over adjacent. Let's try to put that in. Tan, instead of theta, we write 20 degrees equals opposite x over adjacent 30. All right, so now we have this function. When we're dividing by 30, all we have to do is do opposite operators to move it over to the other side. So we're going to move it over. Now we have 30 meters times tan of 20 degrees equals x. So now we just have to type that into our calculator. Tan 20 equals, and that equals, 10.9 meters high. All right, and it's going to be a very similar situation for this next one. We're talking about a flagpole. Maybe we got the little, maybe we should make it red, hey? Maple leaf, you know? For Canada. Anyways, so we got ourselves a flagpole. And we have a person over here. And they're wanting to know, well, if this is a 5-meter flagpole, how far away am I from it? Now they're wanting to know this distance here, if I see it at an angle of 30 degrees. So now, with that said, we need to do kind of an opposite of what we had before, because now instead of missing the opposite side, we're missing the adjacent side. So we have to do the same idea. Tan of 30 degrees equals 5 meters over x, over the missing side, the distance, the horizontal distance. And now we have to move things around. So we're going to move the x over here and the tan thing over there. So now we're going to have x equals, so we just multiplied by x on both sides, canceled on the right, equals 5 meters divided by, because we divide on both sides by the tan 30 degree function, divided by tan 30. And now we can solve for our answer in our calculator. So 5 divided by tan 30 is 8.6, well, 66, so we'll just round it up, 8.7 meters. And I hope that this video helps you guys understand angle of elevation, grade, and distance, especially when it comes to the tan function, a little bit better. Good luck!